Welcome to the Phoenix Spacecraft Entry, Descent, and Landing Simulation. Computer simulation of what we think will happen on Sunday, May 25th, 2008. On May 25th, Phoenix will land near the North Pole of Mars. Phoenix enters the atmosphere going over 12,000 miles per hour at a very grazing angle, about 13 degrees. The very shallow angle will allow us to take advantage of the very thin atmosphere of Mars to slow us down as much as we can before our parachute opens up. This robotic vehicle is controlled by itself. It has its own computer on board that controls all of the events that you see that take place in the simulation. As the vehicle hits the top of the atmosphere, it will start to warm. The heat shield, which protects the vehicle from this heat, is an ablator. An ablator is a heat shield that actually has material that leaves the heat shield that takes the heat away as the vehicle goes through the atmosphere. Without this ablator, the vehicle would burn up in the atmosphere. Instead, while the heat shield will get over 1,000 degrees Celsius, the inside of the vehicle never gets above room temperature. As the vehicle enters the atmosphere, the vehicle is transmitting what it's doing and where it is and what its orientation is to our orbiting spacecrafts, Mars Reconnaissance Orbiter and Mars Odyssey. These vehicles have been timed to fly overhead about now. Unfortunately, all this hot gas that surrounds the vehicle prevents the signal from making it to our orbiters. It's not until it slows down later on that the signal will actually make it out to the vehicles to let us know how it went. As you can see on this display, on the lower left there is a horizontal velocity indicator as well as a vertical velocity indicator. On the left there's an altimeter. It tells you how high this vehicle is above the surface of Mars. On the bottom is a profile of the trajectory the vehicle is taking through the atmosphere of Mars. On the lower right is our landing site. You can see it, it's in green. On the lower right there is a clock that tells us how many seconds to the next event. In this case, the next event is the end of the plasma blackout. On the upper right is the number of seconds left toward landing. Now that the plasma blackout has ended, the signal can be more clearly seen from our vehicles that are flying overhead. In the case of Odyssey, Odyssey is taking these radio signals and relaying them back to Earth, where 15 minutes later this signal will arrive at the Deep Space Network and be interpreted by our team in the Mission Control Area here at JPL. The next event is parachute deployment. This is where we launch a cannon that launches the parachute into the free stream behind it. Now this inflation happens very quickly. But quickly the parachute slows us down to about 120 miles per hour. Under the control of the computer, the heat shield is released. It falls away harmlessly to the ground. Seconds later, the 3 lander legs are released, preparing itself for landing on the surface of Mars. The Phoenix landing site, although very far to the north, is actually very low relative to the Mars atmosphere. So for this reason, this part of the entry, descent, landing timeline is much longer than it was for the 2 rovers that landed in 2004. We spent over 2 minutes falling on the parachute at very high speeds. Right now, we're still over 150 miles per hour as we're descending. At this point, the radar has been turned on by the computer, and the radar is searching for the ground. It's sending a pulse to the ground and back up to the vehicle, and from that pulse, the vehicle is able to figure out how fast it's moving with respect to the ground and how high it is. The parachute used by the Phoenix lander is the same parachute design used to land both the Viking missions in the 1970s as well as the Mars Exploration Rover missions in 2004, as well as Mars Pathfinder in 1997. Once the vehicle is low enough to the ground, the onboard computer decides that it's time to release the lander and let it fall away from the back shell. As soon as it does that, its engines will start. There are 12 pulsed engines. After running itself, the first thing the lander does is move away from the back shell of the parachute so it doesn't make recontact during the descent. And in a very short period of time, the vehicle will slow itself down and land a little bit over 5 miles per hour. As soon as we land, the helium that pressurized our propulsion system during landing is vented. This keeps the hydrazine from potentially leaking onto the surface of Mars. "20 minutes later, the solar panels are deployed. These solar panels will provide the needed electricity to operate the vehicle for the rest of the mission. A few minutes after the solar rays are deployed, the vehicle puts itself to sleep for about half an hour. Once it wakes up again, the camera will be deployed, the biobarrier that covers the robotic arm will be released, and the vehicle will start taking pictures of the solar panels and of the biobarrier. A few minutes after that, an orbiter flies overhead, which will allow us to relay the first images from the surface of the North Pole of Mars back to Earth.